Hello, I'm doing problem number 15 from the physics book. So let's first start out by sketching out the circular motion of this object. And it's starting out right here. And I'm saying that the radius of this imaginary circle is 3. And then it goes, so it's going to have a constant speed, which means it has a constant tangential acceleration, but there's always going to be the centripetal acceleration. But it undergoes a displacement of 9 radians, so a full circle is 6.28 radians, so then it would be an extra like 2.72-ish radians, which would land us around there, and that becomes 156 degrees. So if we just draw the new position vector, r, then theta equals 156 degrees. We see that the new position vector that asks for, okay, so we know that the radius is 3, so then we can use our equation that's like radius times cosine theta I plus sine theta j for circles. So our radius is 3 equals r, which is the position vector. So our radius is 3 meters, and then the cosine of 156 degrees in the I direction, and then sine of 156 degrees in the j hat direction is the position vector. So that's A. Now for B, it asks which quadrant it's located, and that would be the second quadrant because 156 degrees is between 90 and 180, so that's the second quadrant. And the angle it makes with the positive x-axis, that's pretty straightforward, so that would be, since we started from there, then that's the positive x-axis, so it's going to be 156 degrees. 56 degrees is second quadrant. Okay, so what we're going to do for part C, which is the velocity vector, so we're going to be taking the similar components of the position, so we're going to make it the velocity vector is equal to the magnitude of the velocity times negative sine theta I hat plus cosine theta j hat. And so we know that the velocity is 4.5 meters per second, and the angle is 246 degrees, and I'm going to explain that momentarily for part D, and it leaves us with this velocity. Now we get to D, which is pretty tricky. So this asks us, in which direction it's moving. So it wants us to make a sketch of the velocity and the acceleration vectors. So since our velocity is going to be pointed this way, because that's how it's going to be. So it continuously goes in a circle, so it's going to be making a right angle. And then since we have no tangential acceleration, because it's only accelerating, because it's a constant velocity, but there's going to be a centripetal acceleration, so that's going to be pointing inwards. There. So let's just rearrange those vectors. So if we just move this velocity vector over, just parallel to over here, v, then it keeps that same angle with the position vector. So then this new theta of the velocity is going to be, theta of the velocity is going to be 156 plus 90. So for that, we get 246 degrees is the which angle the velocity is going at. Okay, and then for part E, what is this acceleration? So for acceleration, we see that it's always going to be pointing in towards the circle. So that means, and that's making another 90-degree angle with the velocity. So then it's going to be right here, acceleration, which is 180 degrees from the position vector. So the angle of the acceleration is right here, will be 156 plus 180, which is 336 degrees. So there's not going to be any tangential acceleration, and tangential acceleration is the derivative of the velocity, but there's centripetal acceleration, which is v squared over r. And in this case, it would be a big pain to be using this velocity because you'd have to FOIL it. So if you just do it, if you just get the magnitude of the acceleration, which would be 4.5 meters per second squared divided by a radius of 3 meters, which is going to equal 6.75 meters per second squared. Then what you could do is you could make it into the component form. So then what you would do is you would kind of like from up here, you do acceleration centripetal, the magnitude of it, times negative cosine, because you're taking the derivative again from this above statement, negative cosine of 336 minus sine of I hat minus sine 336 j hat meters per second squared. And that's going to be 6.17 I hat minus 2.75 j hat meters per second squared. And lastly, F, which ironically is about force. That's really straightforward. So your F in the x direction is going to be 4 kilograms times 6.17 I hat, which equals 24.7 newtons. And then your force in the y direction is 4 kilograms times negative 2.7 5 meters per second squared. I forgot meters per second squared. In the j hat direction, so that equals negative 11 newtons. Okay, thank you very much for watching.